Hello students, how are you all? As you all know that we were discussing about the chapter differentiation. Today we are going to discuss about differentiation of inverse trigonometric function by using substitution method. Now for substitution method, you all are required to revise inverse trigonometry. Here you can see one question written. Y is equal to sine inverse 3x minus 4x cube. Now, if you do direct differentiation, in that case, the question becomes very lengthy. And of course, when the question becomes lengthy, you get confused. For that, you must know few formulas. First, I will explain you some substitution methods, and then after that, we will apply them. We have done all this in the chapter inverse trigonometry. Substitution method. When we talk about substitution method, if the equation is given in the form of a square minus x square, in that case we put either x equals to a sine theta or we put x equals to a cos theta. Now, this is the first substitution. Second, if we have a square plus x square, then we put either x equals to a tan theta or x equals to a cot theta. And if we have x square minus a square, then we substitute x equals to a cosec theta or x equals to a sec theta. Similarly, if we have a value like under root a square minus x square upon a square plus x square, here we substitute, put x square equal to a square cos square theta, and so on. Now, if we see this question here, sine inverse 3x minus 4x cube. I hope you know few formulas of sine 3x. The formula of sine 3x is 3 sine x minus 4 sine cube x. Very important formula. Similarly, cos 3x. I hope you know the formula of cos 3x also. It is 4 cos cube x minus 3 cos x, and so on. Now, if you look at this question here, y is equal to sine inverse 3x minus 4x cube. It looks like this formula. Sine 3x equal to 3 sine x minus 4 sine cube x. So, we substitute here, put x equals to sine theta, which implies theta is equal to sine inverse x. So, y is equal to sine inverse 3 sine theta minus 4 sine cube theta. We know 3 sine theta minus 4 sine cube theta, it will be equals to sine 3 theta. This cancel out, we get 3 theta. So, y is equal to 3. What is the value of theta? Theta is sine inverse x. Now, differentiation. dy upon dx. Now, do the differentiation. It is equal to 3 into derivative of sine inverse x. So, it is equal to 3 into 1 upon under root 1 minus x square. So, the answer is 3 upon under root 1 minus x square. This is how to do the differentiation of y equals to sine inverse 3x minus 4x cube. Now, let us solve another question. The question is y equals to tan inverse 2x upon 1 minus x squared. Again, think. what substitution can we use? In class 11, I think you have done this formula. That is tan 2x is equal to 2 tan x divided by 1 minus tan square x. Here, you see it is given 2x upon 1 minus x square. If we replace x with tan theta or tan x, then we will get the answer. So, we have to use the substitution. Put x equals to tan theta. So, when we substitute x equal to tan theta, what is the value of theta? Tan comes here. It changes to tan inverse x. So, y is equals to tan inverse 2 value of x is tan theta divided by 1 minus tan square theta. So, it is equal to tan inverse tan 2 theta. So, tan cancel, we get 2 theta. So, y is equals to 2 theta. And the value of theta from here. What is the value of theta? Theta is tan inverse x. So, y is equal to 2 tan inverse x. Now, differentiation. dy upon dx is equal to 2 into derivative of tan inverse x. And we know what is the derivative of tan inverse x? That is 1 upon 1 plus x cube. Because derivative of tan inverse x is 1 upon 1 plus x. So, here you can see the question is done. So, to do or to solve these questions, it's very important that you know the formula. Very, very important. Right? Now, let us discuss another question and try to solve by your own. The question is, differentiate y equals to sine inverse 2x upon 1 plus x cube. Now, how we will do the differentiation? Again, think about the formula. Sine inverse 2x upon 1 plus x square. Have you done some formula regarding this? Okay, just keep in mind that 2 tan x upon 1 plus tan square x is equal to sine 2x. This is very, very important to learn the formula. Another formula I write here, 1 minus tan square x upon 1 plus tan square x, it is equal to cos 2x. And 2 tan x upon 1 minus tan square x is always tan 2x. So, keep in mind these three formulas. Now, we are going to use these three formulae one by one. Here, the question is y equals to sine inverse 2x upon 1 plus x square. Now, it's something like this. Why we are converting it into sine? Because sine inverse and sine, they cancel out. So, we get only one inverse trigonometric function. So, here, put x is equals to tan theta, so that theta, we bring tan here, is equals to tan inverse x. So, y is equal to sine inverse 2 tan theta upon 1 plus tan square theta. So, it is equal to sine inverse, that is sine 2 theta. Sine cancel out, we get 2 theta means 2, value of theta is tan inverse x, that is 1. Now, differentiation, dy upon dx is is equal to 2 into 1 upon 1 plus x square. That is 2 upon 1 plus x square. That is the answer. Now, let us do some more question. This is just a base. Keep in mind, these are not difficult questions. Here, you have to use your concepts which you have done previously. So, don't get confused that these are very difficult questions. No, these are easy. Just go through your books and try to solve these type of questions. Let's solve another question. Y is equals to sine inverse 1 minus x square upon 1 plus x square. Now, just now we have written some formula. That is 1 minus tan square theta upon 1 plus tan square theta is equal to cos 2 theta. For that, here put x equals to tan theta so that theta is equals to tan inverse x. Use this substitution for this. What do we get? Y is equals to sine inverse 1 minus tan square theta upon 1 plus tan square theta. So it is equal to sine inverse 1 minus tan square theta upon 1 plus tan square theta is cos 2 theta. So it is equal to sine inverse cos 2 theta can be written as pi by, how to write cos 2 theta? Now we have to change cos 2 theta into sine theta. How we change? We know cos theta is equal to sine pi by 2 minus theta. So here it comes sine inverse, we change into sine pi by 2 minus 2 theta. So here sine it get cancelled. We get pi by 2 minus 2 theta. So pi by 2 minus 2, what is the value of theta? Tan inverse x. This is y. Now differentiation. dy upon dx is equal to derivative of pi by 2 minus 2 tan inverse x. It is a constant. Pi by 2 is constant. So its value is 0. Minus 2 derivative of tan inverse x is 1 upon 1 plus x squared. So answer is minus 2 upon 1 plus x squared. This is dy upon dx. So you can see only you need to learn is substitution, and rest proceed in the similar way you get the answer. You can see another question written on the board. Y equals to tan inverse 1 minus cos x divided by sin x. Now here, which formula can we apply? Just go back and think. Go back doesn't mean you go back at your room and think. Please go back to the inverse trigonometric chapter and find out. It's 1 minus cos x. We know 1 minus cos x is 2 sin square x by 2, and 1 plus cos x is equal to 2 cos square x by 2. And also we know the formula of sin 2x, that is 2 sin x cos x. Now here we have to change 1 minus cos x divided by sin x into tan x, so that this tan inverse and that tan it got cancelled. So apply the formula. Tan inverse 1 minus cos x is 2 sin square x by 2, and sin x, if we have 2x, angle is xx. But when the angle is x, it becomes half. It should be 2 sin x by 2 cos x by 2, half of the angle. So sin x changes to 2 sin x by 2 cos x by 2. So 2 cancel, 1 sin cancel. We get tan inverse sin x by 2 upon cos x by 2. So it is equal to tan inverse tan x by 2. It cancel out, we get x by 2. So y is equal to x by 2. Now differentiate with respect to x. So dy upon dx is 1 by 2. So we got the answer. The derivative of tan inverse 1 minus cos x upon sin x is 1 by 2. So this question is over. Let us do another question. Now, very important question. Y is equal to tan inverse cos x divided by 1 minus sin x. Now, here you can see in the numerator we have cos x and in the denominator we have 1 minus sin x. Now, how we solve this question? There are different ways to solve this question. Let us discuss the first way. First part. We know cos 2x is equal to 2 cos 2x is cos square x minus sin square x. That is the first way. Now, we use this method. Cos 2x is cos square x minus sin square x. Otherwise, we can even use another method. Let's solve it by first simple way, then we make it another way. First here, y is equal to tan inverse. You change this cos x into sin x. How to change? Sin pi by 2 plus x is cos x divided by 1. Here, what do we have? 1 minus, okay, here in the question it is given to us plus. So it is 1 plus sin 2x is written as cos pi by 2 plus x. Now, keep in mind very important fact that cos pi by 2 plus x is equals to minus sin x. It means when we change this sin x to cos pi by 2 plus x, we have to put here minus sign. So here it comes minus. So we get tan inverse. Now this is sin pi by 2 plus x divided by 1 minus cos pi by 2 plus x. Apply the formula of sin 2x here. Tan inverse 2 sin half of the angle pi by 4 plus x by 2 cos pi by 4 plus x by 2 divided by 1 minus cos pi by 2 plus x is 2 sin square pi by 4 plus x by 2. Now, 2 cancel. We get tan inverse 1 sin got cancel cos pi by 4 plus x by 2 divided by sin pi by 4 plus x by 2. So it is equal to tan inverse cot pi by 4 plus x by 2. Now change this cot into tan. So we get tan inverse tan pi by 2 minus angle pi by 4 plus x by 2. So this tan and this tan, they got cancelled. I'm erasing this part. So here we get pi by 2 minus pi by 4 minus x by 2. This is what? Derivative. 0, 0, it's minus 1 by 2. So the answer of the given question is minus 1 by 2. We will solve this question by another method also. So we will discuss it tomorrow. Till the time, practice and keep yourself safe. Have a nice day. Thank you.